hopefully you can see my screen now.
Yeah, all good.
Okay, great stuff. Okay, so thanks for the invitation to present this work today. So I'll be presenting on the climate change impacts of ocean circulation that are relevant to the UK and Ireland. I'm Gerard McCarthy. I'm the Irish Climate Research Unit based in Maynooth University. There was a large range of people contributed to this from 12 institutions across the UK, Ireland, France and Germany. So thanks to all my co-authors as well. So to start off with, the large-scale circulation of the North Atlantic has a very large and potentially outsized role in terms of the climate of the UK and Ireland. In particular, a lot of attention gets given to the Gulf Stream system. So this is the Atlantic Meridional overturning circulation, which includes currents such as the Gulf Stream and carries warm water northwards in the Atlantic and returns cold water back at depth. And it plays a very large role in maintaining the relatively mild climate of northwestern Europe for the given latitude. Now, we're of particular concern about the AMOC in terms of climate change because the AMOC is projected and has been projected for an awful long time to weaken in response to climate change. This could potentially lead to a cooler, drier and stormier future for this region. So the first question to ask is what is happening in terms of the Atlantic Meridional overturning circulation, and the answer to that is that it depends on which timescale you're looking at. So when we look at the time period from the 1980s, and I appreciate that there's a lot of lines in this particular figure here, if you look from the 1980s onwards, you'll see that this range, this compilation of AMOC proxies and reconstructions shows a strengthening of the AMOC through the 1990s, a weakening through the early 2000s, and potentially a strengthening in recent years. But overall, when taken from 1980 onwards, we have really not got much of a trend. So overall, in the period that we're confident about the variability or the observations of the AMOC, we don't see any particular trend. Now, that an overall trend is not necessarily does not mean that the changes in the ocean circulation are not so important. So we know, for example, that shifts in the Northeast Atlantic circulation lead to a change in the biogeographical distribution of ocean ecosystems and ocean species in this region. So, for example, some of these marine ecosystems are economically important fish, such as mackerel, and these respond to the changing overturning circulation and the changes in the subpolar gyre. That's what's illustrated here on the right-hand side, where we can see the rolling mean of the habitat, which are the black lines, are compared with a decadal prediction system, which can predict where these species end up, more or less by predicting how the ocean circulation is changing. So in spite of there being no clear overall trend in the AMOC since the 1980s, we have begun to see some strong trends that are associated, or we believe that are associated with the AMOC. So we heard from Richard a little bit about the changes in the sea surface temperature in the previous presentation. So we can see this again here on the top right hand side, but in particular for this talk, we draw attention to the change in sea surface salinity, SSS, which over the time period that's presented on the lower figure from 1950s onwards has been strongly freshening. The subpolar gyre, in fact, recorded its freshest values on record in the 2010s. And this is of concern for future stability of the AMOC, because this is very closely linked with freshwater forcing is very closely linked to the slowdown in the overturning circulation. So ongoing freshwater buildup in the Arctic Ocean has the potential to exacerbate this freshening in the North Atlantic, with potential major climate consequences for the North Atlantic. So we know that there are changes occurring in the North Atlantic associated with changes in ocean circulation, and in particular with changes in the Atlantic Meridional overturning circulation and the subpolar gyre. Some of these changes are at least qualitatively consistent with what the models are projecting. So in this figure here, we show a range of the most recent CMIP6 coupled climate modeling intercomparison project and the iteration before the CMIP5. The black lines show the historical variation, and the coloured lines show future scenarios based on varying greenhouse gas emissions. more or less we are locked into a slowdown in the overturning circulation to 2050, and that's actually regardless of what climate change mitigation procedure goes on. So if we have good mitigation, we end up with a reduced overturning circulation after, less of an overturning weakening after 2050. But until then, all of these models suggest that the overturning circulation is going to weaken in the coming decade. Very likely that the aim of the 21st century because of these models agreeing to such an extent. Focusing down a little bit on a more regional level and moving away from the broader North Atlantic, this is the circulation on the Northwest European shelf. The Northwest European shelf is home to a number of systems of ocean currents, including slope currents that separate the open ocean from the shelf, and a myriad of coastal currents that go around the islands. The Northwest European shelf is important for economic reasons in terms of fisheries, but also it plays a disproportionately large role in the carbon transport and in the ocean sequestration of anthropogenic carbon. So changes to ocean circulation on the shelf are of distinct significance. However, unlike certain large-scale oceanographic phenomena such as the AMOC or subpolar gyre, the long-term monitoring of transport pathways around the Northwest European shelf is quite limited. One of the exceptions to this is the Johns's section. So the map here shows the Johns's section just coming off the Orkney Islands. The Johns's section covers the inflow to the northern North Sea. And this long-term observations has shown that salinity-driven flow is really increased in the wintertime when the Atlantic flow is principally wind-driven, while temperature-driven flows dominate in the summer. This the seasonal variability, and on longer timescales, the decadal variability of the salinity of the North Sea has been linked to fluctuations in the wider Atlantic circulation, and in particular the fluctuations in the subpolar gyre. This idea about the connections between the shelf and the wider Atlantic Ocean being the kind of dominant, or at least the most predictable element of future shelf changes is consistent. So future changes will manifest through changes to oceanic source property, temperature, salinity, nutrient load, and then also to the more local and probably less easily determined factors such as local surface heating and prevailing wind and storminess patterns, which we'll hear a little bit more about later. The example that's shown here is one scenario where the impact on net primary productivity, particularly in the North Sea, is highlighted. The greener colours are showing a future where we have less oceanic inflow, and so the nutrient supply isn't coming so much from the open ocean, but more from the fluvial inputs, from riverine inputs, which you can see coming in from the Severn in the Southern Irish Sea and from the Baltic Sea as well. However, robust climate projections for shelf circulation can be challenging, as the uncertainties can arise from both the parent models, which are typically at a much coarser resolution than you need to resolve these shelf circulations, and also some uncertainties arise from the downscaling methods that are used to get down to the scales that are necessary for shelf circulation. So just to bring this to a conclusion, changes to the AMOC. So reconciling the reconstructions of the AMOC, where we've seen a relatively stable AMOC since the 1980s with some notable decadal fluctuations, and the climate simulations, which don't simulate the same level of decadal variability, is a key challenge that underpins our confidence in future projections. So the focus of the understanding in terms of circulation change should probably not just focus on the AMOC, but also with elements such as the subpolar gyre and the driving processes being key to emerging understanding. Finally, we draw attention to the fact that the accumulation of Arctic freshwater is a concern, particularly in the Beaufort Gyre, and its release could have major consequences for the stability of the AMOC. Now, projections do consistently show a weakening in the future, but concerns exist about whether these current generation of climate models could overlook the possibility of an AMOC collapse. Certainly, this generation of models is more or less not capable of simulating an AMOC collapse, so it means that this is a risk that is probably not fully explored. Ocean circulation is not only a threat, I guess, in terms of AMOC collapse, but also the key to predictability on decadal timescales. And leveraging this skill offers the potential for policy-relevant timescales of forecasting. Finally, the weather and biogeographical impacts of ocean circulation change have been studied, but the economic impacts of these changes are not well understood, and we highlight that as a key link between the impact of the ocean circulation change research and the economic impacts of it. Changes in shelf circulation. So features on the continental shelf have shorter both timescales and spatial scales than the open ocean, and this causes a challenge in terms of their observation and their simulation. For related reasons, gas need to be improved through model improvement, and this can come through better methods of downscaling the large-scale climate models, or a better simulation of processes and higher resolution of the overall models. Observations also need to be maintained and sustained so that we can validate model simulations and fill fundamental gaps in our understanding. So thank you very much, and I look forward to seeing your questions later.